Hello everybody. I'm making this small video here to demo the ClojureScript compiler plugin. This is a new plugin. Plugins are new in FlowStorm and are a way of visualizing your recordings in a specialized way for a specialized domain. In this case, it's a way of visualizing recordings you have for the ClojureScript compiler. So you can compile something with the ClojureScript compiler, you record it, and instead of just using the normal functions, like normal functionality of FlowStorm, you can use like specialized one, like to represent your recording like this. What we are seeing here, for example, is the compilation represented as a graph, like as a bunch of stages. First, the reader is going to read a form. You just type it. I have a REPL, a ClojureScript REPL here, where I can put ClojureScript forms, and I'm going to compile them and record that and then visualize that. So what we see here is like we have the reader running, which the reader is returning whatever it reads. In this case, it's this simple form here. Then we have a second stage, that is the REPL wrapping, which is when you type something on REPL, the ClojureScript compiler is going to wrap it into some other forms it needs to evaluate on the browser after, or on Node.js or whatever. Then this form gets into the analysis stage, which is going to, if you look at the return, it's going to generate an abstract syntax tree, which is some nested maps with like different operations. And that abstract syntax tree is gonna go into the emission stage, which you can, if you see the return, it's gonna generate some JavaScript. We can take a look at this JavaScript. If you, I don't know, output, we put it a name on this, and we come here and print it. Okay, so maybe we can see it a little bit better. Here's our function. Wrap it in a bunch of other try catch stuff and whatnot. Okay, but another interesting aspect of all this is that we can jump to any point in time. For example, like if you want to jump into like the wrapping part, we can go to the return of that, and so we can jump here, and from here we can use all the normal FlowStorm tools to debug that point. But there's also, for example, the analysis graph is expanded into a subgraph here, which represent all the analysis process is doing. You see some different coloring here, for example, and it's what is grayed out here. It's all the analysis of the wrapping forms that the ClojureScript compiler adds, because we can still see it and work with it, but most of the time we're not interested. So here, what is colored here, it's basically the analysis of our form, of this form we inputted here. On each of these nodes, if we zoom in a little bit, we can see that we have like analysis nodes and parsing nodes. This analysis node, for example, are basically calls to the analyze star function, and we can see like the form it is currently analyzed, and if it's some passes where like the effective, like after the compiler analyze something, it's gonna make some passes on top of it for like type inference or whatnot. And if it's a passes apply it over the ESD, we're going to see it here, and then we're going to see parse nodes and how this analysis and parse interleave. For each of those, we can, for example, click the args and we can quickly see whatever this analyze was called with or whatever it returned. And also, if, for example, we can also jump to, for example, I want to go to the call of this. So here we are at the core of analyze and at that specific point in time. So for this specific form, and we can step over it and do all that stuff, but also for the inferences. For example, if you are interested in the code that this run like a inference type was run on top of this AST, we can double click here and jump into that specific path. So if we go back there, we can start like stepping or checking like the inferencing type running on this specific thing. So yeah, we can go to also the return of everything or check everything. Here we have basically all these nodes because basically all these subparts, it's dealing with the analysis of the meta of our function, and this other subtree here is dealing with the form itself. This meta is coming from, if you basically go to whatever the reader it's reading, you see it's reading some form but with some meta, and the meta contains all like the source and the lines and stuff like that. So there is analysis on top of that because there's gonna be maybe some emission on that. On the emission side, we have the same thing. So it's gonna be like grayed out the emission of all the stuff related to the wrapping of our thing. This is probably a bunch of things related to emission of the meta, and these are things related to emission of our own form. Emission nodes are also show up here. Let's zoom in this a little bit. What the AST operation they are dealing with. So if you look at the args, for example, this is dealing, the first argument here is dealing with an operation of binding, and you can also see here also on this list here that this is emitting different JavaScript pieces of strings. And again, if you're interested in how and when like this piece string is being emitted, you just double click there and you jump exactly there where we are emitting this piece of thing. And now we can move around and use the rest of FlowStorm. Now we're here on emission. Another interesting part is that, for example, things like this, which is like a Java IO string writer, which is a mutable thing. If you have this plugin, it's gonna add snapshot values for all these mutable things that the compiler uses. So then you can snapshot them and you can see how they change and their content. So they are not like, because this is an opaque object otherwise. So for example, if we can check here, for example, for this particular expression, if we keep on the same coordinate, we jump to the first instance that tried to write something there, this was empty, and now we move next and we start seeing here how the things are being built. Like every time this is called, we can see how the compiler is writing stuff there and we are moving around on the timeline. So yeah, we can try like how I normally work with this, and which shows like the interactivity of all this stuff. If we can, I don't know, we can clear all our recordings. Let's say we want to run a different form here, okay? And what we do is we just hit recording, we compile that form, it's gonna have the records for us. We are recording this on flow 0, so we can stop recording. We have come here, we select the flow ID, we recorded things, we just hit refresh, and we should have the graph again, but this time for this other expression. So I think this is a nice way of like navigating the compiler recordings. Now what I want to do is go back a little bit and start everything from scratch, so you can see how we like what it takes to set up this, and then maybe we can have some fun, like modifying the compiler somehow to see how we can use all this tooling together with interactive Clojure programming and all that stuff. So let's kill everything here, this REPL and all that. Okay, so what I have here, it's the latest master we have now of ClojureScript compiler, and the only thing I changed it is like that is depth hidden. I added the FlowStorm alias with the plugins configuration as it is described on the plugin page. So nothing else. Just with this, what we do here on the project is we just start the REPL with the alias, with the storm alias, and now we can connect. Let's connect from a terminal another REPL there, so we can make it like transform it in a ClojureScript REPL. Okay, so here now we have like two REPLs pointing to the same JVM process. Now let's run CLJS main with REPL, with that only option. Okay, so this just started the ClojureScript REPL, which spawned this browser window, which this is connected to. So if we type things here, it should be evaluating, compiling and evaluating things there. I'm going to leave this aside and let's start the debugger. And let's make the font a little bit bigger for the demo. And okay, so now that we can evaluate things here, let's hit record, paste whatever. There's another simple function that's gonna do some let bindings and a sum, and when we hit enter, it's going to compile that. But now we are gonna have the recordings, and that's it. Now we can come here and generate, click this reload button, and after selecting the float, and generate the graph. Okay, we're gonna leave this here on flow 0. I think something we can do now, have some fun. It's try to I don't know, like hack or implement some very simple like constant propagation, constant folding thing, because I don't know, if we look at the source of this, for example, so we can do print line, let me see, if we do print line of the string of foo, I think we can look at the source. And if we look at the source of this, it is the JavaScript, the generated JavaScript is doing like a 1, B2, and then summing them up. And if we had like an optimizing compiler, these constants are going to be propagated here, like this 1 going to get here, 2 going to get here, and then because everything is constant, this will convert in something that just returns 3. So at compile time, this is going to return 3. So at runtime, it's just a function that returns 3. It doesn't need to do any addition. The ClojureScript compiler doesn't do this kind of thing because it's the JavaScript JIT is gonna do it after, I think. So yeah, let's say we want to implement something like that. So what we can do here, for example, instead of we can come here, try to find the node that is dealing with that addition. It's probably around here. Let me zoom in. So this is the LED bindings, and then it's doing here like a sum. Oh, here. So here it's the analysis stage. If we want to do some very hacky constant folding at this analysis stage, let's say that this is when we are analyzing this a plus b here. If we view the return, okay, so this is returning an operation like a JS operation, which has JS operation plus, and then the arguments. And as we can see here, the arguments in this case are all constants. So one idea could be, what if here, instead of returning this operation, we just return, we figure out first in a pass, in one of these passes, we figure out that we are dealing with this, which is a plus over everything constant, and we can replace maybe this by just a constant, like a constant operation, one of these, like constant operations. So let's try something like that. So first, what I would do, I don't know, we can go to this call here. So yeah, now we are here. We can maybe open this piece of code on Emacs. So we can right click any form here and do open on editor. Oh, damn it! I have like another Emacs instance here, and it jumped there. So we can do. Let's open it. It's here. So it's this is analyzer, CLG analyzer, though I think it's this one. Yeah, there we are. Okay, so now we have like we can take a look at these passes. Passes are all these passes is coming from here, and it's coming from default passes, which we have all these default passes. The passes are just things like are just functions, and if we look at one of them, that we can do by, I don't know, double clicking here, for example. So passes are just functions that receive an environment, an AST, and some options, and should return another AST. So what we can do here is to, okay, here, well, we just have arrived here, we have the default passes. So I guess we can add here some, I don't know, it's gonna be, I don't know, constant folding. That's gonna return and it's gonna have an environment, an AST, and some options that I don't think we are gonna use. So the idea here is, what if we look at this, for example, if we go to this function call here, when we are here after analyzing the form, before running the passes over it, we can grab this AST, which is the return of the analyzed formula, which is the input to it's going to be the input to our passes. So let's try to see if we can identify the situation. So if we are if our node contains like an OP.js and a plus and everything is constant, we are gonna change it. So one thing that makes it easy to develop is like we can do like define this thing here. Let's call like AST or whatever. So we can have access to this by doing like I never bother with the namespaces and everything. I just put them on user. So now we have like AST here. So if we do keys or whatever, we are going to have it there. This is going to make this easier to implement because we can call constant, like we can do a comment here and do constant folding. We do this doesn't matter, and this is going to be our user AST. And this doesn't matter for us. Okay, so we need here, we probably need to check if we are in this kind of situation, like this node here, and if not, we are going to just return the AST. What do we need to check here? So from the AST, we are going to need to check that the operation. So maybe we can extract it from here. We're going to need the operation and the JS operation, and yeah, we can try here if the operation is JS, and also we have like what the JS operation, the JS operations are here. We need to be like the symbol CLJS core plus, okay, and also we would need to check that every one of the arguments. So we need the args here also. Okay, like that every one of the arguments, and the arguments, it's a collection of things that have these things like init, and so let's do the same here, maybe do like this. Okay, so we extract init there, and we can check that the operation of that init, it's constant. It's called const. Okay, so if we are in this situation, we can maybe grab our value. We can go and sum up all these constant values. Okay, so let's and then we grab that value and we return one of these AST nodes instead. So it's going to be an operation constant with the value, whatever value we calculated, let's call it some value or something, and yeah, okay, and I don't know if we need anything else like operation and value, and what else do constant have? It has a form, a tag, but we are going to ignore the stuff for now. Okay, let's see what happened if we do that. So now we need to calculate this sum value, which is something we can do here. So this is the nice thing about like defining things, because now if we want to, we can do something, I don't know, like AST, like the user AST, we're gonna get, we already have the, we can do that like this. We already have the args there, but just so we can try the expression here. So we have the args, and on each args we are going to map those args. We are going to map the init, so we need a function on this of the arg, and we are just going to do, I don't know, get in of the arg. Let's do init val. Okay, we can try this here, I guess, by just evaluating this. Okay, makes sense. Now do reduce with plus all that. We can try it here. Looks fine. Now we can, I guess, safely remove this because the args, we already have it there, the structure. So this looks good. And yeah, I guess we can try. So we can compile this, and we can try the constant folding now here. Let's get rid of this for a second. And I guess we can try the constant folding of that, and it looks fine. For that AST, we should be returning something like this. So let's add it to our default passes here. I don't know, in the beginning, constant folding, and reevaluate this also. And now let's see what happens if we execute the same thing again. Okay, so we run that, and now let's see the whatever JavaScript this generated, and we see that we broke it somehow, because now it is it's null here. So now we can bring back the debugger and try to see what is going on. We can use another flow for that, so we don't lose our recordings on the previous thing. That is the thing that was working. We can use as a reference. So let's go here now, and let's hit recording, and let's try this thing again. Okay, there, and now we record everything but on flow 1. Okay, yeah. So now when we come here to this, we can see. Let's create the graph on the on this other on the recordings of this other flow. So first thing we need to do is that let's check that the thing we did was effective. This is very slow because I'm streaming on an old laptop, and so yeah, let's try to find out the sum part. They are here. We can already see that it's that our constant folding, it's running here. It's running on a different node than the one we intended but this is because these two analyze calls return exactly the same value, so the constant folding is running before, but it's there. So if we look at it now, what is this like something returning? If we view the return value, it looks fine. So these other things were added by the other passes, and yeah, so this part looks fine. Okay. And so what we are missing here is like we are missing two things, like the return and the value. The return has to do if we load, let's load the other graph. Okay, if we load the other graph, the return thing has to do with when we are on a return path. So it's an expression that it's in a return position, not in a like in statement position. You are going to see that that I don't know. Let's check any of these. It's gonna be it's gonna have an environment with a context of return. That's what's supposed to generate the return instruction. So that's one thing we are going to need here. We are going to give it like an environment with a context of return. Okay. And yeah, and the other thing we can check like on the emission. Let's see a little bit about the emission of the thing we just did. So it's, instead of the analysis, now it's gonna be some emission for our stuff here. Should be around here. Okay, here we can see that we are emitting for our constant, we are emitting null. So we can go to that call of emit, or why we are like emitting null here, and we can look at the stack here. This is coming from emit constant, so we need to go a little bit back. Okay, some more emit constant thing. This is coming from where? Okay, here. So this is, we are emitting our constant node, and the thing here, I figured out that the emit, instead of emitting like the value from the operation, it's emitting the value from the form, which is weird. I would expect that the compiler will emit the constant of the value of the operation, because the constant operation has have a value. But anyway, we can come here and also like create a form like it had before, because the operation also has a form, and now we can put this as a form. So yeah, let's try now. We try that and that, and let's see if what happens if we compile this again. And now we can try to copy and print the sources of this, and great, we have done some constant folding. So we can try it with well, yeah, with different arguments or more constant. It should work the same. And yeah, but I guess this kind of shows how we can use all these tools together with interactive development, where we never we are modifying something as complex as a compiler without without having to restart the JVM or the REPL. Everything is super fast, in the sense that we can run like come here and type something to compile a specific form, and then look at it with the debugger. We can compare many runs of different syntaxes of compilation and all the stuff. And yeah, I think that is all I wanted to demo. I hope people find this useful. Okay, see you next time.